In 2013, Explorer 1 accomplished a noteworthy achievement by becoming the first human spacecraft to enter interstellar space. Completed this feat 36 years later, leaving Earth. The ongoing observatory is now 14.5 billion miles from Earth, causing messages to require around 20 hours and 33 minutes to be sent and received. NASA specialists didn't anticipate that Explorer 1 would continue space exploration for more than half a year. However, the vehicle far surpassed expectations by finding 500 obscure objects in space. Now, world-renowned podcaster Joe Rogan has joined the conversation to share the mind-blowing aftereffects of this unprecedented disclosure. What are these secretive objects? Are they connected with extraterrestrials or a failing plane? Join us as we investigate how Explorer 1 identified 500 obscure objects drifting in space and what Joe Rogan's unimaginable discoveries might mean. Have you ever wondered why, despite the incomprehensible vastness of the universe, we don't pursue concrete proof of extraterrestrial civilizations? This issue is called the Fermi paradox, and it has intrigued researchers for years. However, a recent encounter in the depths of space has shocked scientists and may shed light on the age-old question of whether extraterrestrials exist. Joe Rogan, a specialist and podcaster known for discussing extraterrestrials and the possibility of advanced extraterrestrial civilizations, has recently hosted guests like David Grush and other analysts on this topic. Now, new data from Explorer may first be the key to answering the question of whether we are genuinely alone in the universe. Buckle up as Joe Rogan explains why Explorer 1's declaration that it has identified 500 objects traversing space is a game-changer and what it could mean for you, regardless of where you are on the planet. Before we dive into the exciting part, let's understand how Explorer 1's mission came about. Isn't it amazing to imagine that our brilliant world, with its vast seas and towering mountains, is just a tiny part of the greater universe? Researchers have pondered this for years, but it was only after the 1970s that NASA researchers had the opportunity to determine the size of our astronomical neighborhood. Everything began with the startling alignment of the 4 largest planets in the solar system: Jupiter, Saturn, Uranus, and Neptune. Amidst this celestial dance, a graduate student named Gary Flandreau, who worked part-time at NASA's Jet Propulsion Laboratory while studying at Caltech, stumbled upon an astonishing discovery. By carefully computing and plotting the orbital paths of the giant planets, Flandreau found a phenomenon that would change space exploration. His discoveries were truly groundbreaking. In the late 1970s and early 1980s, these 4 planets were tracked in an intriguing pattern, like pearls on a vast necklace with Earth among them. This revelation generated excitement at NASA since it offered a rare opportunity to improve space travel by utilizing gravitational assists from each planet. A spacecraft could propel itself forward using a force akin to the pull of invisible cosmic strings. Flandreau's hopes suggested that gravitational assists from the giant planets could reduce the flight time between Earth and Neptune from a daunting 30 years to just 12 years. However, this grand arrangement occurs only once every 175 years. Recognizing the significance of this once-in-a-blue-moon opportunity, NASA embarked on a mission to explore the planets. 2 spacecraft, Explorer 1 and Explorer 2, were built with the same design and mission, launched 15 days apart in the summer of 1977. The twin pioneers aimed to uncover the secrets of the solar system and beyond. Explorer 1 was launched on September 5, 1977, and became a crucial part of the Explorer program, a testament to humanity's curiosity and quest for knowledge. For nearly 50 years, this extraordinary spacecraft has continued to travel, sending valuable data back to Earth via NASA's Deep Space Network. It has become our eyes and ears in the vastness of space, bridging the gap between our known world and the unexplored realm beyond. While marveling at Explorer 1's incredible journey, it's important to note that it is now only a breath away from Earth. As of August 2023, the observatory is an astonishing 14.5 billion miles from our planet. Carefully designed and built by the brilliant minds at NASA's Jet Propulsion Laboratory and powered by the Titan III launch vehicle, it began its mission from Launch Complex 41 at Cape Canaveral Air Force Station. When you think you've seen it all, reality unfolds. Now let's take a deeper dive into this astonishing mission of 500 obscure objects drifting in space and the captivating explanation Joe Rogan recently provided on the Joe Rogan Experience podcast. How did Explorer 1 reach interstellar space? Imagine a spacecraft venturing into the great unknown and navigating the vastness of deep space within a decade. That is Explorer 1 for you. This daring spacecraft is now an incredible 14.5 billion miles from our planet. Take a moment to ponder this distance. It is equivalent to traveling around 3.6 times the distance from Earth to the Sun in 1 year. But there's more to Explorer 1 than speed, distance, and longevity. It also revealed a major discovery, including the new finding of 500 obscure objects hidden in the vast expanse of space. This finding is unlike anything we have seen or analyzed before. It is a treasure trove of immense mystery and wonder, and we are about to uncover the details of this discovery. You may wonder how a spacecraft launched in 1977 is still operational and providing such exciting data. The answer lies in the remarkable engineering and vision that went into Explorer 1's design. One of the key secrets to its longevity is the presence of 2 backup computers. Explorer 1 and its twin, Explorer 2, are equipped with 2 computer subsystems, the Flight Data Subsystem and the Attitude and Articulation Control Subsystem. This redundancy is a clever move that ensures the robustness of systems and the ability to activate computer components when needed, prolonging their lifespan. The computer system on the Explorer spacecraft is designed as a distributed system comprising 3 redundant computers. This smart planning ensures that even if one of the systems fails, the others can handle the mission seamlessly, preventing primary objectives from being compromised. To maximize limited power usage, Explorer systems rely on wired logic. Computer systems are designed with intricate algorithms that work within energy budgets and time constraints. Power management during spacecraft development was a critical factor in maintaining operational integrity. Explorer 1's distance from the Sun poses a significant challenge to its ability to harness solar energy effectively. To maximize energy efficiency, engineers had to find innovative ways to optimize energy use. One such strategy involves prioritizing power for essential functions. Engineers carefully examined parts or subsystems that were non-essential to the mission. For instance, the heaters of some scientific instruments were disabled. These heaters were intended to keep the equipment at a certain temperature for effective operation. When turned off, they reduce energy consumption, extending the overall service life of the spacecraft. However, decisions about power management for essential functions are not taken lightly. It involves a comprehensive assessment of trade-offs between energy savings and mission objectives. Engineers work closely with scientists to ensure that disabling certain systems does not compromise the quality and usability of scientific data. The goal is to find a balance that maximizes energy efficiency while maintaining critical performance. Explorer 1's power management system can adapt to changing conditions as the spacecraft moves farther from the Sun. As solar energy decreases, Explorer 1 adjusts its power usage accordingly, ensuring sufficient resources to support essential operations and data transmission. It's like having a smart energy saver on board. Over the years, significant technological advances and improvements have been made in power management. Engineers continue to refine Explorer's power use through advancements such as enhanced power delivery, improved battery charging systems, and sophisticated electrical and thermal management. Thanks to these effective energy management techniques, Explorer 1 has exceeded all expectations. Just 6 months after its launch, it continues to provide crucial insights. Given that this spacewalk was first conducted only a few decades ago, its longevity is truly remarkable. It speaks volumes about the dedication and ingenuity of the scientists and engineers who work tirelessly to maintain Explorer 1. However, let's not forget that the depths of space are full of surprises. So stay tuned as more discoveries are on the way. Intended to explore the vastness of the solar system and beyond, the Explorer mission is equipped with an impressive array of electronic instruments and systems. These instruments were integrated into the spacecraft's fuselage, consisting of 65,000 individual parts. Although Explorer began its interstellar journey with an array of functional devices, only 4 remain operational on Explorer 1 and 5 on Explorer 2. One of the long-term instruments on board is the low-energy charged particle instrument. This device features 3 sets of particle sensors that measure the number and speed of low-energy particles hitting it, detecting cosmic radiation and detailing the sun, planets, and interstellar space. A companion instrument, the Cosmic Ray Instrument, actively seeks high-energy particles from the sun and other cosmic sources. Cosmic radiation instruments now detect materials emitted from deep interstellar space and the protective bubble formed by the sun's influence. These readings are crucial in determining when Explorer 1 entered interstellar space. The device remains functional on both Explorer 1 and Explorer 2, featuring two long antennas at right angles to each other. The plasma wave subsystem is a key tool for measuring the electromagnetic field of potentially unseen exoplanets. However, its role evolved as Explorer entered interstellar space. Today, the device provides data on how plasma waves change as they travel through space. Additionally, the magnetometer, originally designed to study the magnetic fields of outer planets, now plays a significant role in exploring the transition zone between the solar system's inner layer and the core. Researchers use this instrument to investigate the magnetic properties of the changing region where the sun's magnetic field interacts with magnetic material on the sun's surface, providing insights into how planetary magnetic fields evolve over time. It is crucial that the magnetometer remains functional on both Explorer 1 and Explorer 2. Another significant instrument is the plasma sample, which detects low-energy material in the plasma environment. It can observe objects moving at specific speeds and determine their origin within a predefined range. These resources become increasingly valuable as the spacecraft ventures further into space. However, it is important to note that the current measurement only functions on Explorer 2. Although some of Explorer's instruments have been purposefully or inadvertently switched off to conserve energy, the plasma exploration instruments on Explorer 2 continue to prove valuable for scientific research. Furthermore, in an effort to preserve energy, NASA introduced heaters on both spacecraft in 1998. Each spacecraft can have up to 3 radioisotope thermoelectric generators, RTGs. These generators use the heat produced by the decay of plutonium-238 to generate power. However, as plutonium-238 continues to decay, it will eventually no longer be able to provide power, leading to the potential shutdown of the entire device. This is expected to happen around 2025. Each Explorer spacecraft is equipped with 2 engines, not to propel the spacecraft forward, but to reposition the antenna so it always points towards Earth. This maneuver is crucial for maintaining communication with the spacecraft. The engines fire brief bursts or pulses lasting a few milliseconds to precisely pivot the spacecraft and align its antenna towards Earth. In November 2017, due to the degradation of Explorer 1's primary engines, scientists activated the backup engines. This action allowed Explorer 1 to re-establish contact with Earth after nearly 4 years of silence. Remarkably, the backup engines are capable of adjusting and orienting the spacecraft's antenna, even if it remains dormant for extended periods. The primary transmitter of the Explorer spacecraft transmits approximately 20 watts of power, equivalent to the light emitted by a refrigerator bulb. When the Explorer signal reaches Earth, its power has diminished by 20 billion times compared to a digital watch battery. Despite the remarkable performance of the Explorer spacecraft since its launch, it is worth noting that your iPhone has multiple times more memory than the Explorer spacecraft. Now that you have a better understanding of the Explorer mission, buckle up as we delve into the history of the 500 mysterious objects recently discovered in space. The data sent by Explorer 1 was initially confusing, attracting the attention of mainstream scientists with its latest revelation. A spacecraft inadvertently discovered 500 obscure objects hidden in deep space. This discovery has raised concerns among researchers because these mysterious objects remain enigmatic. Importantly, the initial data sent to Earth was distorted, akin to a garbled message from afar. Imagine the surprise on the faces of scientists at NASA's Jet Propulsion Laboratory when they realized they had recovered this perplexing information from the far reaches of space. After thorough investigation, the source of confusion was traced to the Attitude and Articulation Control Subsystem, AACS, a critical component of Explorer 1 responsible for measuring, reporting, and correcting the spacecraft's orientation in space. The AACS is equipped with antennas pointed towards Earth to transmit data back to our planet. Scientists recently found that the AACS had been using an incorrect computer, which had been dormant for years, causing disruptions in telemetry data. NASA engineers promptly resolved the issue by reconfiguring the AACS to accurately send data from the correct computer. As a result, Explorer 1's telemetry data is now streaming back to NASA scientists as expected. However, the lingering question is why the AACS was using the wrong computer. Although NASA scientists cannot provide a definitive answer, they speculate that the AACS received incorrect instructions from another onboard computer.